Okay, let me continue. So as I mentioned to you, this standard ETL, okay, it contains several steps to modify the data. Okay, so to change the data before you do the analysis. So you can check this following process to change the data. And after we have this ETL, okay, after we finish with this standard ETL, we select the attributes. What does it mean by select attributes? So you already know when we have the data, we will not use all the attributes for the analysis, or we cannot use all the attributes for the modeling. Okay. So in this case, we will exclude the churn date, hash code, postal code, row number. We will not include those, but we will select only the important attributes for our classification or for the regression. Okay. And then here there is a process to change the nominal to numerical. Okay. Some of the data maybe it is necessary for us to create into the numerical. So let's say, yeah, gender. So gender, we have male, female, and payment method. Okay, we have cash or credit card. Yeah, you can put with the text, but in programming, it will be good if you can convert the nominal into the numerical. You can try without this nominal to numerical. You can check later here. And then we can also do more things like what we can see here is, yeah, there's a regular expression. Yeah, because now I'm not teaching you about the regular expression. If there is an issue with your text, okay, I forgot. I guess there is one team who wants to analyze the social media. Okay. So if you are dealing with the social media, I guess you will need this regular expression. So it's a kind of challenging, but you can try. So after we have this, we can go back to the process. Okay, so the ETL finish. Yeah, if you can include like this explanation, yeah, first, yeah, you need to review the existing sub-process, and then yeah, anything, yeah, that you can explain, yeah, it will be good here. And then after we have the data which is ready for the modeling, so we can go to this modeling. So here we only have one, which is decision tree. Okay, just let's see with this one. And we use the gain ratio and the maximum depth, which means the depth of the tree. So we know the tree will have branches. So we want to have only at maximum 10. And after we have this, the other parameter, I guess it is default. When you already have the parameter with the decision tree, you can see here, we can split to training and testing. Okay. And you can do the apply model for the testing. In this case, yeah, usually you don't need to do anything, just put the model into this apply model and then put testing into this apply model, so you can find what is the performance. And you can see here the performance contain of many metrics. So you can have the accuracy, or you can include also the classification errors. You can include the kappa and so on. Okay. Let's say, yeah, if you want to input the classification error. Okay. And yeah, after you finish this, you will show all the result and you can run. Now you can see that this accuracy is 79.14% with this kind of plus minus of the accuracy. And then the prediction and the true, yeah, and the prediction of loyal, okay. So yeah, we can see like this number. Okay, so the true means the actual, the customer churn, and the prediction is also churn. But we want to see the customer is loyal. Actually, it is loyal, but the prediction is churn. So it's, yeah, the customer didn't use the product or didn't use the service again. We can have the plot, but I think the plot is not that good. So you can see also the classification error. Actually, the classification error is like 100% minus the accuracy. Okay. The error equals to the 100% minus the accuracy. So that's the common meaning. Okay. And then you can see the precision. You can see the precision. You can see the recall. Okay. So you already learned in the classification about the precision and recall. What does it mean? Okay, then it seems that it is quite good. Yeah, with almost 80% of the accuracy. Okay, now how if we want to change the model? Maybe there are some of the models which are not ready in the RapidMiner. Let's say, yeah, we learned about so we learned about the samples. So the samples here is about the process, the learner. So we have, yeah, nearest neighbor. We have naive bias, support vector machine, logistic regression. But they are actually old modeling techniques. And let's say I want to get the new one from Python. So I want to get the new library. So you can install the library and then you can use the library in RapidMiner. Okay? You can use the library of Python in the RapidMiner and you can execute it. So in this case, okay, just let me give you very easy way. So I would like to save this one. So I would like to save this environment in my current computer. I want to save the process in the local repository. So later, if I want to get this one, it's easy for me. Maybe, yeah, for Python connection. Maybe I can just give you this way. And then I already put another process. So basically the process is the same, but the other process I use Python to conduct the cross-validation. Okay. So the cross-validation here. So I use the execute Python. So here I use the execute Python, which is using the sklearn. Yeah, if you are familiar with the sklearn, yeah. sklearn is one of the library in Python for the machine learning, for the data mining, and you can extract this library into RapidMiner. And then you can import any algorithms, any functions in Python into this rapid miner. So you can, yeah, of course, you need to do something more in this data stuff. It means you need to define the predictor, okay, or this is the attributes that you want to use for the data mining. And after you have this all attributes that you want to use, okay. So if it is the predictors, yeah, then yeah, you can use it as the predictor. If it is the attribute, okay, so you want to put it as attribute, and we have the base. The base means the data which is based on the attribute name. And then we call the decision tree classifier, and we want to fit it. Fit means, yeah, we want to do the modeling. After we do the modeling, you know, in Python, we have the mechanism to do the prediction. Okay. After we can do the prediction, we can create the performance matrix. So in this case, yeah, we will use the same sklearn, and then we will use the function. So in this case, now we have two input, which is model and data. And yeah, again, we declare the attribute names. The attribute names that we will use, this one is, yeah, some name in the columns. And then, you know, let's put a variable name base to indicate all the data. And then we want to predict. So this is a new column. So we create a new column prediction, and then we want to predict with the function in the Python. And finally, yeah, we will make the prediction for the next stage, which is the performance. Why is error? Okay, let me check. Seems there's an error here. Okay, then if you finish with this modeling, let me check if it is working or not. Okay, yeah, it's working. Okay, the result is 67.81%. Oh, it's lower. It's lower than the previous one. Do you know why? With Python, the result is lower. Is it true? Actually, if you use this Python, the code that I shared to you is without any parameter. Okay, the decision tree is using default parameter, and the default in Python is different with the default in rapid miner. That's why the result is different. Okay, so if you want to use Python, you need to declare. For example, yeah, in the decision tree classifier, we can define like the maximum depth. What is the maximum depth that you want to define? Let's say this is 10. And yeah, any other parameter that you want to use. Let's say you want to use the cross validation. So yeah, those kind of parameters should be defined in order to make the accuracy higher. So let me save this process in my local repository. This, let me just give the name this one. So if you take a look on the process that I put before. Yeah. So in the decision tree, yeah, you can see. Can you see in the right stuff? Okay. This is the parameters that have been defined by the RapidMiner. Of course, if you change this criterion, yeah, it will affect the accuracy. Let's say, let me change to Gini index. And then let's change to the minimal gain is not 0.01, but 0.1, for example. Okay. Okay, this is still almost the same because I think the tree is not that. Yeah, the tree is quite good. Okay. So let me just do some default without pruning. Okay, maybe the tree is not that high, so the result is still the same with this kind of parameter. So with the Python, you need to adjust the parameter with this kind of environment in order to get the same, or almost the same result with this. Okay. Okay, so yeah, you already know how we can do with the Python connection, and yeah, you already know how we can deal with only with the RapidMiner. So you can choose. Okay, if you want to use the RapidMiner only, that's fine. Or if you want to modify with your Python file, that's also fine. It's good for your practice if you want to know about Python and how to connect Python in the RapidMiner. Okay, so yeah, this is the result. We can see that before the Python script, yeah, we use the model from the RapidMiner, and with the Python script, we use the scripting from Python to make the model. Okay, okay, I think that's all for the RapidMiner. For the remaining stuff, I hope that you can try by yourself. And before this one, I think we need to discuss about the possible time for you to meet me. As I mentioned to you,